Più secondi. Io mi metto l'altro guardo e lo stesso Sorry, we have a little problem, technical problem.
It reminds me that, whenever Peter Eisenman is lecturing, he's saying, I'm old, so I'm sitting. And so he's lecturing always with a table and a seat. And so I find myself sitting today, and it's great. It's very good. And I'm not old.
It's working. Okay. So welcome everyone, and welcome Aaron. The 2024 ACC lecture series, entitled Limits of Architecture, Architecture of Limits, proposes a cycle of 12 seminars curated by a team of students in the program Architecture, History and Project to open up a discussion among researchers, architects, designers, and other professionals in related interdisciplinary fields. And our aim with this cycle is to delve into the concept of limit, transcending the physical realm into the virtual, social, disciplinary, technological, and philosophical aspects of architecture. And today, Professor Aaron Sprecher will present a lecture titled The Human Limits of the Human Being, Intensities, Extensities, Potentialities. And Professor Aaron Sprecher is an associate professor at the Technion Faculty of Architecture, where he founded the Material Topology Research Laboratory. His research and design work focused on the synergy between media theories and computational design, examining the way in which technology generates transdisciplinary approaches to design processes. Aaron Sprecher is co-editor of numbers of publications and books, and between them we have Architecture Information in 2013 and Instabilities and Potentialities in 2019. So I give the microphone to the professor for his lecture.
Thank you very much. Thank you very much. So let me just do this here. I hope you can hear me. It's okay? Okay, very good. Great. It's a real pleasure to be with you today. I also know that some are actually joining us online, including most probably the members of my lab at the Technion. And so it is very much of an international event today. And so it's a pleasure, real pleasure to be here. Thank you, Professor Armando, for your kind invitation to share a few notes on this fascinating question regarding the limits of architecture in the age of computation and automation. That is for my part today. I also want to extend my gratitude to Marta Rossi, and the DESP student team, because really, you took care of all the pragmatics to make it happen today. So thank you very much. I feel especially honored to join you as Alessandro and I had the opportunity to engage on related questions a few months ago in Berlin. The question was then on the fundamental role of technology in the current fusion of architectural and natural assets. And so I'm delighted to pursue this discussion today. The title of this lecture is The Human Limits of the Human Being, and it comes as a reference to Norbert Wiener and his seminal work entitled The Human Use of the Human Being. With its release in 1950, Norbert Wiener proposes a theory on communication, what we call cybernetics, and the questions related to the nature of communication between humans, animals, and machines for Wiener implies necessity to control the message, or in other words, its source and recipient. I will basically try to control the message today as well. Norbert Wiener declares, when I control the actions of another person, I communicate a message to him. And although this message is in the imperative mood, the the technique of communication does not differ from that of a message of fact. Messages between men and machines, between machines and men, and between machines and machines are destined to play an ever-increasing part. It is precisely the limits of such communication that are central to Norbert Wiener. He pursues, much of this book concerns the limits of communication within and among individuals. Man is immersed in a world which he perceives through his sense organs. Information that he receives is coordinated through his brain and nervous system until, after the proper process of storage, collation, and selection, it emerges through effector organs, generally his muscles. These in turn act on the external world and also react on the central nervous system, and so on. Such a description implies the necessity to consider the value of information in terms of its capacity to exchange with the outer world, therefore allowing us to adjust to it and make our adjustment felt upon it. As Norbert Wiener states, to live effectively is to live with adequate information. Thus, communication and control belong to the essence of man's inner life, even as they belong to his life in society. This question regarding the role of information and related technologies of communication and control was central to the 39 Rencontres Internationales de Genève in 2003. The perception of reality in terms of information and technology was addressed by a number of researchers from various domains of scientific research. Among the participants, the philosopher Michel Serres proposed a model of knowledge based on our technological capability to gather, associate, and connect information. The human ability to stream and screen information has prompted an exponential development of technologies that projects man to the origins of life while propelling a future built upon evolutionary processes that are, in fact, increasingly fast. The emergence of new sciences based on the nature of information, such as genomics, biochemistry, computational biology, I would like to say computational architecture as well, has in fact accelerated our evolution and adaptation. This acceleration results from the ever-increasing specialization of technological tools. As Michel Serres puts it, what is in fact technology? It is a great economy of depth and time. He considers the tool as a source of condensed time. In other words, the growing specialization of technical tool brought about a swift progress in terms of human evolution and adaptation. Compared to the long and patient evolution of nature, Michel Serres points out that technology has in fact intensified time to the limits of human comprehension. Michel Serres sees technology as a function of intensity, the intensity to memorize and associate pieces of information that are collected at all scales. For the French biologist Henri Atlan, this exponential development of technology has transformed our perception of the world, and in particular its representation. One of the main consequences of this vision is the blotting out of the distinctions between living and non-living organisms for Henri Atlan. He believes that science has created a continuum between conscious and non-conscious being by considering them being made out of the same material substance, information, but with a differentiated organization. While obvious differences exist between living and non-living organisms, as well as between conscious and non-conscious beings, science has also recognized a substantial unity if considering their biological processes of evolution. So for Henri Atlan, it is a matter of limits between the human and the environment. And these limits are increasingly blurred by the mechanical character of information reported across nature. To the scientists who continuously scrutinize molecular and atomic interactions, nature seems indeed animated by increasingly mechanical laws. And I know that when I'm saying this, or when Henri Atlan is saying that, this has some ethical consequences. But that's, in fact, what's happening in the sciences. And this model of nature does not announce a post-human era, as some would claim, but instead the emergence of a model where the human is no longer idealized and limited to a particular terrain. In this model, people are more than ever connected to the world. For Henri Atlan, information has erased the limits and rendered a reality in constant extension. A reality that is made out of abstract and extensive mechanisms that are continuously self-organizing and recombining. In response to Michel Serres' technological model of intensified evolution and Henri Atlan's extensive nature of the human being, the physicist and theorist Roland Omnes, in that same conference, observed that our model of nature are rooted in a series of laws that are limited in numbers and yet highly condensed in terms of information. In fact, in that lecture, Roland Omnes had a slide where he showed that you can summarize the whole phenomena that you see in nature out of 10 or 12 equations. So it's a very, very condensed number of laws that may actually unfold all the natural phenomena that we observe. With the exponential development of technology, the laws have in fact generated models that combine both intensive and extensive sets of operations. These laws tend toward a continuum of principles that bridge the macro scale and the micro scale observation of matter. They make up a world that is inherently mechanical as we find them everywhere. Classical laws like the principle of relativity or abstract laws like the quantum theories. For Roland Omnes, the nature of these laws and mechanisms express potentials for the unfolding of dynamic processes that takes place in nature. This model of experimental thinking rests on the concept of addition. The addition of a wide variety of principles induces the emergence of potentials that are combined and merged with the ultimate goal of rendering a comprehensively organized world. He writes, there is no such thing as cause and effect, but a combination of potentials, an addition of all the events that may occur outside of any constraints. Roland Omnes' model of potentiality is interesting to us because it considers the nature of information. With its capacity to flow across all domains of research, information has in fact increased the confluence of knowledge on the technological platform that is increasingly integrated, but also reconfiguring under the influence of parametric potentials. In the coming 3 slides, you will see some of the works from Tamar Levinger, who recently graduated from the lab. Her research was actually concerned with the first days of what we call digital architecture. And she basically, in her thesis, that is, by the way, available over internet, she's showing that in the lapse of a few years and 3 main exhibitions in the late 60s, early 70s, we can see that the whole theory of digital architecture was actually already planned and based. And she worked a lot in working with historical documents and building those mappings that you will see now. From the point of view of today, informed architecture, or what we call parametric architecture, the notions of intensity, extensity, and potentiality suggest that the discipline has transformed the nature of its object, the architectural object. This object has mutated into more what we call an evolutionary system that is shaped by intensive computational operations that inform, influence, and modify its nature. The capacity to manage the complexity of information inherent to this entity has become dependent on our calculation capabilities. So following Michel Serres' principle of evolutionary rate, the architectural organism is now the object of an accelerated evolution. It has become endowed with an exponential capacity to absorb and process complex sets of operations. This computation capacity does not depend solely on intensive processes. It also embraces a condition of extensity, pressured by computational tools that were primarily developed in other domains of knowledge. Today's architectural organism is no longer autonomous, but depends instead on a wide range of research domains. One of the consequences of this transdisciplinary state is expressed by the current proliferation of design activities in emerging fields such as material and fabrication research, interactive and immersive media, and most noticeably, what we called biologically inspired modeling. As the American architect Greg Lean once noted, in the near future, it will not be surprising to see architects designing molecules in scientific labs. In other words, the expansion of information and its associated technologies implies that architecture is increasingly porous to other fields of knowledge. Its concerns are no longer constrained to a particular dimension, but extend at all scales, from the structure of a material to the macro scale of environmental phenomena. Now, what is very interesting is that while we see the proliferation of virtual machines and engines in architecture, they are actually fueled by a great diversity of information that blurs the limit between, I would say, the living and the non-living. We take parameters that can be about the social, that can be about the cultural, that can also be about the material and about the physical. And we put all that within our computational models. And so I would sustain that architecture has now embraced what Henri Atlan considered as a model of extensity by creating a continuum of knowledge that expand at all scales. And this continuum has radically transformed the nature of the practice. By embracing a great diversity of information and technologies, the architectural entity went from being an idealistic object to what I would call a statistical one today, and that in the lapse of 30 years. Technology has exponentially increased its ability to add parameters, therefore producing models that are too often idealistically called emergent models. We hear a lot about people saying this is an emergent architecture. And yet the redundant use of that term emergence or the emergent is not surprising in view of our contemporary reality that appears more and more unstable and mutable. I'm here in Italy, so I had to put something from Super Studio. I felt that that's necessary. In the past 40 years, roughly since the advent of information sciences and technologies, architecture has undergone in a profound transformation of its status. And yet from Dalegre and Rena Banham environment bubble and Super Studio macro event macro environments to today morphogenetic desires, it remains fascinated with life and its complexity. Considering the three notions of intensity, extensity, and potentiality that act in the most profound structures of our world, architecture is no longer interested only in representing life, but rather in procreating its condition of evolution, adaptation, and duration. The architectural organism is now sensitive, mutative, responsive to its own existence, or as Peter Sloterdijk, the German philosopher, would put it, it now embraces the ambient spheres of our world. I will now show and I will illustrate that across 3 projects that were recently produced that are still, for some of them, ongoing at our lab, at the MTRL lab at the Technion. First project about intensity. And I will try to illustrate everything I said now with, you will see now, a notion of images and videos and so on, for those who like that. Intensity. Our exponential capability to collect and screen information has transformed our perception and relation to the matter, to nature surrounding us. This technological intensity has triggered a condition by which we relentlessly inform our environment. Ofer Asaf, who's right now doing his PhD at our lab, investigates the way such a technological intensity produces computed materials. That's his word, computed materials. or in other words, the way we may embed information in the deeper structure of locally found materials. The raw material is first collected, and what you see here is actually some aggregates from the Raymond crater in the middle of the Negev desert in the south of Israel. A landscape that looks very much like Mars. That's actually being used by the European Space Agency for training astronauts who will go to Mars. And so here, the raw material is first collected and reduced to particle size, therefore allowing a high degree analysis of its physical capabilities using X-ray diffraction and laser measurements. Technological tools are here conceived as a middleware between the natural material and its transformation into a man-made production. Using an iterative method of testing, the soil-based material is combined with 100% environmental materials, including fibers, to reach an optimized mechanical property to sustain its own weight. And I would argue that here already, the material is neither natural nor artificial. It is what I would call already virtual, and I will talk about that in a moment. It turned into a highly informed mixture that is virtual in the Deleuzian terms, a mixture capable of generating potential forms, themselves highly parametric and informed. The virtualization and the actualization of that material takes place from the moment that it gets distributed by the robotic arm into layers that are capable of generating what I qualify as an object in formation, in evolution. And such an object features specific textures and physical qualities as a consequence of the robotic speed and spatial movements. The inherent relation between the tool, the material, and the human generates a potential for specific objects to emerge. More so, the material mixture and the manufacturing tool are computationally probed while forming a scientific approach to what we may call the informatization of the object, how we embed information to the depth of that object. Iterative experiments provide fundamental data regarding the material behavior in the additive manufacturing processes. The movement of the robotic tool, combined with its material distribution, establish a quantitative and qualitative assessment of the material mixture performance. Here, Ofer Asaf develops a research methodology that provides the conditions to both consider the visual and physical behavior of distributed soil-based material and their rheological properties that are key to any additive manufacturing processes. From the standpoint of the technological intensity that we discussed, the control of additive manufacturing parameters, such as the distribution of that material, the velocity, the material elasticity, its curing, all that generates formal effects that add layers of information to the architectural object. Compiling these experimental observations shapes an informational system by which the object emerges out of a specific convergence of material and tooling parameters. The striking condition of this diagram that you see here, that's actually what matters here, is that it rests on the idea of defining the architectural material, not in terms of its appearance or function, but as an organization of information parameters that are capable of forming the object. I find that quite radical in a way, very different than the way we were looking at materials, I would say in the past or in the recent past. The object here acts in radically different mode than the Aristotelian helomorphism that defines the form projected in advance of production by an external productive agent. Here, the homogenization of the relation between the matter, its manufacturing tool, and the emergence of its formal definition reflects what Gilbert Simondon, the French philosopher, defined as a techno-aesthetic process by which virtualization and actualization occur simultaneously. The techno-aesthetic object emerges out of intensive computational operations that negotiate internal and external forces that shape the object. And such forces include parameters internal to the material composite mixture, the type, and design of the manufacturing tool, the method of material deposition, and the design of the deposition movement. Here you see Ofer Asaf together with the MTRL lab, at the MTRL lab, and here with doctoral student Ronnie Hillel. And they are currently applying this fundamental knowledge to ongoing projects with partners from the Faculty of Civil Engineering at the Technion. My dear partners, Professor Arnon Bentour, a world expert in aggregate materials, Oded Amir, one of the top scientists in the field of topology optimization. And here what you see on the screen are some of our recent experiments on high-performance concrete mixtures that we investigate with the objective of reducing by 50% the use of construction material compared to conventional methods of concrete casting. So we started our discussion of today by referring to Norbert Wiener theory on cybernetics, or in other words, the way the communication and control of information are two key aspects of our relationship to the environment. The notions of communication and control of natural resources has always been an essential condition for living in the desert. Ancient societies in the Negev desert, south of Israel, developed unique technologies to harvest rainfall and grow crops. Such communities, like the Nabatean, created vast collecting systems for water management at a scale that can only be grasped from satellite views, what you see here. But back on the ground, these dots that you saw, these ground cavities, reveal a large irrigating network called liman. The architectural object for the Nabatean, for those ancient societies, has always been considered as an interface between the human and its environment, a median space, as the Belgian philosopher Henri van Leer puts it. Here, for instance, you can see in the back of those trees, you can see the remaining walls built by the Nabatean as a way to create a microclimate condition for the growth of olive trees in the Negev desert. Ofer Asaf investigates such ancient methods to harvest the desert using architectural devices to communicate with and control this extreme environment. But for the sake of our discussion on technological intensity, what matters here is that this ancient wall that you see there already expressed the human necessity to mark the landscape, to inscribe culture within nature, or in other words, to inform the landscape that now turns into a performative landscape or a cultural landscape. Ofer Asaf questions the modus operandi of such an informed landscape and the way our contemporary society may address such a technicized nature. Considering the ancient method to harvest the desert by creating microclimates, Ofer Asaf investigates ways to create tree shelters that are capable of generating such climatic conditions for the growth of seedlings. The containers that you see here are made out of local materials that are distributed into highly engineered forms. The shelter becomes part of a nature that is neither natural nor artificial per se. The shelter stems from the ground and provides not only protection to the seedling, but also nurtures it. It is a shelter, a structure, a sign in the landscape. How it is made? Using locally found soil, the craftsman engages in the preparation of a building mixture through wet filtration to reduce energetic demand and dust formation. This process leads to a composite mixture that is ready for manufacturing, a mixture that is highly informed by the printing technology that will be used to generate optimal tree shelters. A high-resolution form stems from the distribution of the natural soil. The envelope, its materiality, thickness, porosity, and height are calculated to provide an optimal light exposure, humidity level, and airflow for the seedling, for the trees. The design of the tree shelter is composed of material layers that are adapted to control erosion. The form is also adapting to the required lighting as a function of the seedling types. The form integrates an optimized approach to airflow as a condition to generate ideal microclimatic conditions in the desert. The architectural dimension of the object results from embedding an ever-increasing range of information in the depth of the material itself. The material is modulated according to parameters pertaining to the biological evolution of the tree seedling, its environmental condition, and the material mixture own necessities in terms of physical and mechanical constraints. So here the object, the architectural object, is not any longer distinct from its environment, but instead it turns into what Michel Serres called a parasite. It turns into a machine that excites its initial environment, it learns from it and modifies it from the inside while acting and reacting on the world. Humans have always searched for ways to mediate their natural environment. From the ancient Nabatean communities to today, technological objects have served as an interface between the human and nature. And yet our human society has never reached such a degree of informing nature. The intensity by which we are now capable of integrating information as well as collecting data has blurred the distinction between culture and nature. It has created a condition by which natural assets are increasingly incorporating technological devices, what I would call a naturalized technology, bringing nature within technology. But we are also bringing technology within nature, and that would create another term that we could call a technologized nature. You see, it's a give and take. It's a two-way integration of nature and technology. Number two, extensity. Now here for today, I have brought in a project following a question that Alessandro, you asked me about mapping and about how that kind of theory would also get translated in terms of cartography. And we have actually a project that just ended up at the lab that I will show to you today. It's a project by Atlan. I can call him Dr. Atlan. He just finished his PhD, so congratulations. And he's about to start his new chapter as an assistant professor at Delft University, leading a group in the branch of preservation. And you will see what Atlan has been about. Along with this condition of intensity that we've seen, there is also the question of extensity. And so the following project exemplifies, in my opinion, the way we may reconsider the core architectural knowledge when approaching the multitude of strata, objects, narratives, and beliefs that composed our architectural history and heritage. Such an approach calls not only to collect and address the intensity of information, but also the way we would structure that information, the way we would network that information. The following work addresses the question of information extensity, or the way we seek ways to embed an ever-increasing amount of information in the depth of the architectural model. This condition is central to the work of Atlan, who investigates the potential for a new form of architectural historiography that is capable of bridging tangible and intangible histories. As Atlan describes, in this image, we see the neighborhood of Wadi Salib. We see the ruins of Wadi Salib across the street. We see also the court and the Haifa port. We are in the north, in the city of Haifa, in the north of Israel, and we're in the heart of that city. We see a facade of the building being held by scaffolding, the remaining of that building. It is hiding the empty interior of a house. Architectural preservation attempts, and this is what Atlan writes, architectural preservation attempts to stabilize the structure and with it, its history. He pursues, such a facade preservation offers a flat urban landscape. The very word preservation is problematic, has come to be associated with a sort of deference to the past over the needs of the present. It subjugates contemporary action, normalizes it, confines it to legal regulation, and stands in the way of anything new, any alternative to the status quo from emerging. I claim, writes Atlan, that memory through exclusively material presence is often limiting. I attempt to provide an alternative experimental approach through digital and computational tools, which intentionally undermine one stable structure and narrative. To question the stability inherent to the traditional model of preservation in architecture, Atlan addresses a series of dichotomies, namely the past versus the present, the object that is divided from the subject, and the archive that is distanced from the site, usually. Atlan proposes a model of built heritage preservation that he qualified as a mixed reality, or as it stands as the crossing of virtual and augmented reality. For him, such a model suggests a form of assemblage rather than a rigid form of reconstruction that is often the reflection of a single viewed history. He establishes three strategies of assemblage: a temporal assembly that bridges past and present modes of reflection, a transmedia assembly that addresses the sensorial dimension of the historical material by translating textual information into a visual, three-dimensional model, and finally, what he calls a quasi-object assembly that layers information gathered on the heritage site with other archives. Here, the assembly generates what Atlan calls a network of things, or a site archive assembly. At Wadi Salib, such assemblies are crucial because of the contested histories of the site. And that's the reason why Atlan has developed his PhD on that particular site. Wadi Salib is located in the heart of the city of Haifa. It embeds two radically different narratives and heritage. On the one hand, the Palestinian prior to 1948 and the Nakba massive displacement. And on the other hand, the narrative of a rich community of Jewish Moroccan immigrants who settled in the empty houses after 1948. Discrimination against them also drove the birth of what we call the Mizrahit identity, and consequently also brought a planned destruction of the Wadi Salib neighborhood by the State of Israel. As Atlan reports, this chain of events is not unique in Israel. The intensity of the events in this case here is unique. The proposed model of a site archive assembly aims to address such conflicting narratives. It provides the possibility to visually reveal these historical strata by integrating large sets of information from multiple sources, being on-site large-scale scanning, archival documents, and interviews of former residents, among others. The objective of such a model is to ultimately accumulate and organize this information into a multidimensional model that Atlan calls HBIM, or historical building information modeling. And such a platform calls for mixing multiple media with the objective of gathering and structuring a large amount of information strata pertaining to the investigated site. Atlan defines a specific generative pipeline divided into three stages in the formation of what he calls the site archive assemblies. First, networking, which involves collecting and discovering new relationships between the different data that are being collected. Second, juxtaposing, which discusses the potential of automatically mixing various materials based on the network. And third, using AI to transform data, specializing it, and designing a web-based virtual reality environment. So first, networking. Networking aims to connect archival materials, he writes, such as manuscripts, planning surveys, photographs, films, with field work, including environmental scanning using LIDAR and drone photogrammetry of site segments. The assumption here is that the more connections one creates between these different types of information, higher is the potential to create a new perception of the conflicting events and histories that shape the site. Among others, the assembly of textual and visual material led to the segmentation of both archival text, including police reports, government documents, interviews, and physical point clouds collected by the LIDAR scanning. Such segmentation and automated classification of textual data is performed across a dedicated large language modeling that he developed in partnership with a postdoc at our lab, Jonathan Dortheimer, using GPT-3 and 4 protocols and more. Atlan then developed a web interface with a database backend capable of visualizing the complexity of the connections between the multiplicity of narratives and their geolocation on the site. As he reports, rendered linearly, main hubs of dense information emerge. These are locations that are most heavily appear in manuscripts, photographed, maps, etc. A line between them draws a path through the site. The main hubs, Wadi Salib Kasbah, and within it, the Abu Khatzira synagogue ruin, and above it, an area in the upper part of Wadi Salib. In this area, multiple sources mention the Karaman building block, a third hub, referred to repeatedly the stairs that are linking the lower and upper part of the neighborhood. The second experiment that Atlan developed looks at one of those data hubs, the Abu Khatzira synagogue. It examines multiple database structures capable of linking distinct information related to an object. An on-demand interface, one random data node from that hub, is rendered and juxtaposed with a LiDAR scan of the building. Atlan reports, the purpose, the objective of this setup is to assess augmentation, and with it, the potential of a generative process to load unexpectable information and generate various narratives. In this example, for instance, the aerial photograph from 1947 shows Wadi Salib from above, and compared with the interactive 3D model on the left, the photo is informative, static, providing a point of view, not of a human, but of a governance. The notion of extension, bridging past and present, object and subject, is especially important when considering the other nodes in the network, such as photographs. Here, for instance, a photograph by Oscar Tauber that shows how that building that today is actually left over alone was actually part of a much larger system of buildings and of a much more dense urban fabric. Or here, a Palestinian family in 1929 provide a glimpse into the domestic setting in Wadi Salib. The exact location is unknown, yet the image provides valuable information on conditions of domesticity, among others. Textual material provides an additional level of sensitivity to the context. In this one, for instance, we see Eli Fadida, an ex-resident of Wadi Salib, that recalls that the machines coming to destroy the synagogue mysteriously broke down when approaching the sacred structure, stopped by divine intervention. That was just, one of those interviews. In its most advanced stage, Atlan experiments led to the building of a three-dimensional intuitive web environment. And this computation platform generates a database structure with the objective of specializing text, image, and architectural drawings, and reversely transforming spatial segmentation into voice narration. We don't have much time, so I want to actually move directly to that interface so that you can actually see how it looks like. I'm not sure if we will have sound, but if we do, you will hear also some interviews. You can see here how, in fact, the model is actually really multidimensional. It is about the geography of that neighborhood, but it is also about trying to understand and collide all kinds of information that you see actually on the left side, more like layers, like you would have on a CAD software, layers of information that you can actually bring in and out so that you can grasp the different narratives, the different types of information that are actually related, in this case, to the synagogue itself that he actually investigated. Oh, you can hear. What you hear is actually the interview of one of the former residents who was a kid when that neighborhood was still alive and his family was living there. He's actually explaining what was the everyday life. And this narrative that he's telling about that everyday life in that building, you can actually see through the 3D scanning that has been produced by Atlan on the site today. But then, as you can see, you can choose another node. This is Abed Abdi. He's a former Palestinian resident of that neighborhood. And he's going to tell his own narrative. He's today an artist living nearby. And he's, of course, sharing his memories that are also about the materiality of those spaces, more precisely about a particular tile that was actually on the floor of that space where he used to live. That tile, he has a picture of it. And here, Atlan would actually implement that tile in that virtual model. And so you can start colliding this idea of the narrative, the textual, the visual, the archival material, and the site survey. I think that this is an interesting way to approach the complexity of our histories in plural. And here we go. Now you can actually see how that virtual space would look like according to the text or the narrative that, that Abdi is sharing. And in that model, you can see how Atlan now is also bringing in some data from archives that are also accessible online. Okay, we'll approach the last project, which is, again, I'm taking you to a completely different world, but it's another project that is being developed at our lab. I like to call our lab a playground, where actually the PhDs, and I know that I have a PhD audience today, so it's a way for me also to share with you what's the life of PhDs elsewhere. As you can sense, they're all having their own project in the lab that are really based on the kind of theories that I've been sharing with you today. The project that I will show now is a project by Tamar Nix. She's a brilliant industrial designer, an expert in textile design, and I will end today's lecture with that project. It's rather short, but it will show that notion of potentiality that Omnes was mentioning, this idea of the convergence of knowledge that exists among multiple sources of expertise, and the way we are actually creating a network of those different types of knowledge. The project by Tamar Nix best expresses this condition of technological potentiality, such as, for instance, what you will see, the automation of an ancient manufacturing method into a computational platform that is capable of reenacting local traditions and cultures. We are here at the center of the Negev Desert again, in the south of Israel, nearby the Dead Sea site. We are by a place called Nahal Chemar that witnessed the emergence of some of the most advanced ancient communities in human history. During an archaeological mission in 1984, on one of its cliffs, one of the most important Neolithic assemblage has been found. The find consisted of wooden artifacts, fragments of baskets, and plaster objects They were found in a cave along with raw baskets, fabrics, nets, flint stools, and so on. They were actually part of a ceremonial system similar to other Neolithic sites found inside a 30-mile radius of the Judean desert. Many of the fabric pieces found were dated from the pre-pottery Neolithic period, placing them in the 7th millennium BC. In that cave, they found flax fiber items that were processed and also yarns. And the archaeologists divided these items into multiple groups of textiles, including null-binding assemblage, which are an early form of looping or single-thread looping crochet. You know what is crochet? Okay, I will talk about that in a moment. Nahal Khemar cave is noted as the earliest known place of crochet in the world. Crochet textiles were born in this region some 6,500 years ago, and yet the technique never changed since then. Here, for instance, we see a book of samples dating 1885. And as Tamar Nix mentions in her research, the tool is a needle with a hook, which almost didn't change over time. The main change was actually the handle. And yet the hand gesture, its set of actions, never evolved despite the social, cultural, and economic factors that influence the traditions and habits where it took place. Crochet seems to be a constant across our history of craftsmanship. When I was 5 in my Belgian primary school, I had to learn to do crochet. I remember that. As Tamar Nix shows in her research, crochet textile features unique properties, including formal and structural capabilities. It is the only textile technique capable of producing three-dimensional surfaces using the variations and typologies of knots that compose its surface system. Here, for instance, we see an example of one of her early experimentations with architectural scale crochet on the occasion of an exhibition that she did, Thread of Thought, at the Periscope Gallery in Tel Aviv. The scaling up of the crochet technique represents a challenge both in terms of its material definition and manufacturing. To the difference with other techniques of textile making, there exist no machines today that are capable of translating the human gesture of crochet into an automated manufacturing procedure. That's what she's challenging. The difference with two-dimensional knitting, crocheting is based on a single movement with a single hook while producing a highly intricate system of knots, each infusing a specific internal force in the three-dimensional textile formation. As she reports, crocheting allows you to create various shapes using basic stitches that can either reduce or increase the surface area. The possibility to create volumetric textile-based envelopes at multi-scale, including the architectural scale, calls for translating the human gesture and the material desire into a computational code on one hand, and conceiving a manufacturing device that is capable of reproducing such a code. So for the past 4 years, Tamar Nix at our lab has been engaged into the designing and implementation of such a technological platform, a platform that best expresses the potentiality of computational technologies in the age of intensity and extensity. That's actually one of her works that was recently produced. And in this phase, in this experiment, she highlights both the morphological possibilities and the inherent challenges in envisioning the digital fabrication process for large-scale structures. The code dictated a spiral workflow process where each layer relied on the previous one, resembling the layering approach of FDM additive manufacturing. But here she's been doing it by hand, using really big needles that she's been producing, especially for that project. For Tamar Nix, this method has the potential for widespread applications across various fields. In the first study, Tamar Nix drew a parallel between the human hand and the industrial robotic arm. She created a pre-designed point-to-point toolpath for the robotic arm to follow. Using a point-to-point computational protocol and peripheral setup to make crochet chain, which is the fundamental element, the robotic arm then attempted to mimic the human gesture. The experiment revealed that mimicking the human gesture as a strategy for robotic crocheting would limit the scale of manufacturing. In fact, you end up with something that is quite primitive, but you have to try and you have to start from something. Then in a second experiment, Tamar scanned a crocheted surface using a 3D scanner and prepared the robotic toolpath code accordingly. At this phase, we realized that it was really challenging to control soft yarn with a robotic path. In a third experiment, she performed actual single crochet stitches on an existing cloth. In her current study, she looked into analyzing the spatial path of the crochet hook when it performs a single stitch. The single stitch is the simplest crochet unit. It involves a double insertion movement. It is basic unit, but it's still complex. And we employed various approaches to analyze this path using an Intel RealSense short-range depth camera. By recording the manual actions of the single crochet using depth images, Tamarnix was able to precisely isolate the trajectory of the hook tip. Then, in conjunction with the recorded sequence of manual processes, we employed the spatial toolpath of the manual crochet hook to establish the robotic fabrication process. The manual movement angle is reflected in its mechanized counterpart. Here on the left, you see the 3D path of the hook head. In the middle, the trajectory that illustrates the grip of the yarn. And on the right, how we dissect all this into a looping mechanism that will be then used as the design for a machine that will be capable of crocheting. And this is the machine. The division of this ancient method of manufacturing into a series of independent operations offers the possibility to, in the final phase of our study, for our team to actually design a patented digital crocheting device. It is designed to work on the 6-axis robotic arm and to create a volumetric crochet. The robotic end effector is composed of 5 zones: a control unit, a feeding system, a stitching mechanism, a looping mechanism, and the product upper guides. The system mimics the manual crochet process, and as you can see, there is a whole system, and I will be happy after this to explain to you in more details. It is now patented, and it is actually in the production. When the robotic arm moves row by row following the pattern code, the device itself performs the actual crochet stitches. A computing unit controls the synchronization. And so in our upcoming work in the coming weeks and months, it will involve the real-world fabrication of the device, which is currently underway and should be ready in a few months from now. We will then pursue with the building of what will be I believe, the first architectural envelope made out of crochet-stitched textile. Robotic crochet by Tamarnix exemplifies the notion of technological potentialities and our capability to translate complex phenomena such as human gesture, material sensitivities, and traditions into an evolving computational platform. From the point of view of our discussion that we had today on the intensity, extensity, and potentiality of technology, robotic crochet is significant at least in 3 aspects. First, it questions our state of knowledge that calls for a convergence of knowledge. Then, I have to say that her team of researchers for Tamarnix, her team involves computer scientists, mechanical engineers, and so on. Second, this project also stems from the learning of ancient cultures that shaped our region and communities. And so here, crochet is one of the oldest textile techniques that exists in human history, and it remains the only technique that is capable of doing 3-dimensional textiles. And we're about to reenact that ancient technique using state-of-the-art technology. So we are also bridging 6,500 years of history. And third, robotic crochet will provide a significant advancements in many fields of application, as I've been showing just before that, including architectural textiles. So that leaves us only a few minutes for questions. What, if you want to, what I can put in the background now is a movie that we recently presented in an exhibition at the Tel Aviv gallery, a very famous one called Bet Binyamini. It's an exhibition that we did on the subject of trees, because we like trees. And for that exhibition, we produced a movie of a forest, a dying forest in the south of Israel by the Dead Sea, called the Enzine Forest. We decided that we would 3D scan that forest before it completely disappeared. And interestingly enough, it's a movie that is made out of millions and millions of points, of digital points, each one of them with a certain color. The color shows actually the health of those trees. And it shows also the way we are acting on our ecology and our environment is also having incredible consequences on what will be the environment of tomorrow, if not of today. So this is actually the movie. We can, if you want to, we can leave it in the back. It has also a sound because we want to also make it atmospheric. It was a movie that was produced together with Ofer Asaf and Merav Peretz, a dear colleague of us from Shankar College in Tel Aviv. And here you can see some of the views of that forest of palm trees, what remains of it. What you see in red are actually trees that do not succeed to get nutrition. So that's actually the red. This forest has been polluted by a huge chemical plant that has been implemented on the Dead Sea since the 1960s, and that has been actually pumping all the resources of the Dead Sea. And here's the consequence of a human action. So that also is something that for us is very important to take in consideration from an ethical point of view. But there is also something fascinating in terms of the representation. Thank you.
Thank you very much.
We open the floor to everyone who has any questions. I don't know if the professor
Break the ice a bit.
With pleasure.
Because it's been really a very effective and deep demonstration of how we can make research on around the architectural project. I mean, you showed us how the architectural project is something like a technological practice, which is basically technological in the sense you showed us so well, because you showed us that if we conceive our activity, our practice as a technological activity, we can do a lot of things. We go into the space, into the earth, we go into the history and the multidimensionality of the city, we go into the tradition of our handcrafting traditions. And so I think that this is a way to understand that we are everywhere, potentially, and we do need to reinvent our practice, even out of the normally considered building activities and the practice like the office or in the center of the city. I mean, we can do a lot. You are doing a lot. And this is so, inspiring also for our students and PhD students. So I really thank you about this. And then I would have a lot of questions, of course, in all the three, especially for the three things that you showed for me.
But I would like to add one little thing
Yes.
about this, about what you said, Alessandro. As you've seen, and I don't mean to be cliche, this is really the work of a team.
Yeah.
I mean, you see here the work. At some point, as I was preparing my lectures, I had the feeling that I had a critical mass of work that is being produced by the PhDs at our lab. And so in many ways, I feel that I'm like a representative of a large team and of PhDs who are actually also, triggering those discussions. And I think it's very important. There is also a multiplicity that is interesting in this case, a multiplicity of approaches that we can also discuss.
No, I am really impressed because I had listened to you in Berlin, but probably you didn't have the time, the situation for explaining so well all the implications of your activity.
Yeah.
So the collective effort, together with this strong theoretical background that you, since you started today, together with the material activities and the design activities as a whole, all intertwined, like the crochet. There's a crochet of different dimensions of your work, which are not, it's not just for showing something, it's really something that happens because you need this kind of integration among different dimensions of the work. And this is really impressive because it's probably the first time I see such a strong integration among the material laboratory, the technological laboratory, and the architectural design research and practice. So I really thank you for this. So we will talk later a lot. And so I would leave the floor to the students. It would be great to have some questions.
I'm sure that there are some historians and some theorists and some technologists and some who are dealing with computation and some that are dealing with books. And I think that it's actually very interesting to sort of like create that kind of interaction.
Yes.
Please.
I am not an architect. I am here as a PhD student for another field, which is languages and linguistics, but I was completely mesmerized by the second project. I wonder if the second project, apart from having this accumulation of information inside it, might also have some consequences in design or urban morphology, because this is you picture the state of affairs of I'm sorry, I forgot the name of the area, but
Wadi Salim in Qatar, yeah.
But might this project also have some design outcome for designers in the area? Is it?
Yeah. So that project for sure has incredible consequences, both in terms of the way we approach history and the way we would approach a site survey. So of course, we can extrapolate that kind of project, and I think that Atlan is doing that, extrapolating that to investigate urban phenomena and also revealing the complexity of the way we would actually read the city. So that, of course, is a potential application to all this. But since you're coming from the languages, I think, because I was sure you would mention that, one of the biggest difficulties that we have with this kind of system is actually how do you translate the language, the textual language, the text, so it can also be a written text, into a three-dimensional image. Because languages also have, they involve a tone, a meaning, an atmosphere, connotations. How do you do that? This is still highly challenging, and that I think is one of the steps that Atlan will investigate now in his own in that research, because right now what we see a lot are natural language processing (NLPs), where as you know, you take a text, we find the keywords, we use those keywords, we try to to understand from those keywords how we can create some kind of a mapping, but actually languages are far more complex than that. And that translation, I think, was actually one of the major, I would say, it's one of the major challenges that Atlan is trying to deal with. And for sure, when you think about the city, that is today the contemporary city that is made out of so many cultures, made so many social groups, sometimes groups are moving, and therefore we see a lot of movements of people, and therefore a lot of different narratives. For sure, this could turn into a tool that will help informing the design of the city. Certainly.
You consider design must, in a way, have the human being at the center. This is a very important.
Yes, absolutely.
Because from an anthropological point of view, I think this is the most fascinating thing.
And this is the reason why, you know, just to follow up on what you're saying, this is the reason why I think that in an architectural team, you need to have an anthropologist. If you talk about biology, I think that you need to have a biologist. If you talk about computation, you need somebody from computer science. You know, like we need to. And actually, I'll take this opportunity to stress one of the terms. Also in the introduction you made, but I also mentioned that it's the word transdisciplinarity. Okay, I never talk about multidisciplinarity or interdisciplinarity. I use the term transdisciplinarity, and the reason is because transdisciplinarity means that you get around the table with experts from different fields, but each one is recognized with its own identity in its own discipline. So when I'm around such a table, I'm an architect. That's all I can say. I'm an architect. That's what I do. But the engineer is the engineer, and the anthropologist would be the anthropologist and would actually inform such a model. The question is, how can we use actually our technologies to create that kind of convergence of knowledge? I think that that project that I've been showing of Atlan is a project that is attempting to do that. So we need to have a layer called the anthropologist, and then we will need a layer that says the social worker, and maybe also the historian, and all those different layers would then collide into what we could call really, this time, really a deep model, right? Hi.
So I have a question. I have three questions for the second one. As I understand, basically the second project is a library which is 2.0 library. And in a traditional library, for example, in Torino, we have the books, the pictures, the videos. On the laptop, maybe we have the 3D scanning of the building and the radar scan of the structure, let's say. But in the second project, they just combine all this data in one uniform, easy to access system. So the purpose of the project is to just create a mini library, let's say, which is accessible to people, or is create a new model to train AI or train people to be able to understand another project in the same city or a different place without using 2 or 3 or more data. For example, this kind of a house without the human data, the text and all that.
Yeah, I think that the attempt here is actually to create an open system. So it is not a finite model what you get there. What you get is actually a model that to which you can actually add more and more information. You can, by the way, also subtract information if needed. Okay. The interesting part of it is that the fact that you are in this movement of addition, that you are adding layers, may actually inform you or create a different comprehension of that historical event or phenomena. And more so, it may help you to actually understand that there exist multiple narratives on the same spot. That, I think, is also in many ways a political stance in terms of our own discipline, by saying that it is not possible to work with one formal history that is, by the way, usually a history given by a regime, but that actually we need to work with that multiplicity of histories that exist in our contemporary world and confront that complexity. That's a tool that is attempting to do that. So yes, it is about creating a vault, a collection. It is also about bringing more layers. And in fact, it's not here, but you can imagine, of course, that in the next step of this project, it will be to open it online to other residents who did not have a chance to get an interview and that may actually add to this. It turns out that the residents of Wadi Salib are having a Facebook page. There are about 200 still alive. So now we can also add their narratives to that model. A colleague of mine was saying that when you do a PhD, it's 5 years of research, more or less. Depends on the schools, right? But it's actually 15 years of research. So the PhD is a first step towards something that is, that can expand. And I think that that's what Atlan means to do in the coming years. I find that quite fascinating. Also, the fact of being able to connect the archive, which is usually an institution, with the interview that is of a resident, of the memory that, by the way, is not formal. It's sometimes informal. And by the way, you don't always have the possibility to check if it's true or not true. So you are also confronted with that issue. The instability of the model is actually absolutely fascinating. Is that model true or not? It actually doesn't matter so much. What matters is the variations and the multiplicities.
And this spatial explicitation of
Absolutely.
and use the space as a multidimensional index.
Exactly.
It's really, really fascinating the way you do it. Yes.
But I think that it also ripples in the other process that I've been showing. Yeah. So how do you take some historical material, like for instance, from the Nabatean, and you try to reenact the technology that has actually disappeared? And I think that those moments are actually, to me, quite fascinating. Sure.
Thanking the previous question about the fact of the diffusion, because we talked about the archival, the interviews, putting all together in the same platform, and I was curious, what are your aims to diffuse and to let open this platform into the world, make a public website, or how can this be?
Okay, so that, these are this is actually very important, because I think that the dissemination of knowledge is absolutely key in research. The first thing is that I didn't mention that I should sell myself more, but or ourselves as a lab. But in the front page, there was actually the address of a new website that we have, and we have actually collected all the projects that are ongoing on that new website. So I'd be happy to give it to you, and so that you can distribute it. And what you will see there is that there are a lot of publications that are happening from those projects, both in academic journals, but also in all kinds of venues. I actually do believe that we should not be constrained to the academic world, but also to reach the public at large. The research that you see here are actually, these research are being disseminated in multiple ways. First of all of them, the 3 that I've been showing today, but all the rest of the lab, and we're talking about more than 15 researchers today, they're all teaching, or we are trying to have them teaching somewhere during their PhD, so that they can actually disseminate their knowledge and their research among a new generation of architects or designers. Atlan, for instance, in his PhD, a lot of the material comes from a course that he's been teaching, where the students were going to Wadi Salib and were actually interviewing the residents. So he's been training them to that kind of knowledge. Ofer Asaf is teaching a course on robotics and material systems, and Tamar Nix is doing a lot of exhibitions, for instance, which is also something that is very interesting because that also brings the large public around those objects. Now, this said, I think that ultimately the idea for those projects is actually to get into the public. Some of the projects that are more technology oriented are going for commercialization, or that's what you do when you're in a technological institute. So that also happens. So we're trying to work on all those different vectors. But to me, the most moving moment is actually when I see those incredible researchers teaching. Through their teaching, they succeed, to bring that knowledge out. In the case of Atlan, the second project that you saw, I do believe that he will actually pursue that now at Delft University, and he will probably connect that to a much larger network, for sure.
We want to be part of it.
Absolutely, he will be very happy to join, for sure, I'm sure. Great. Thank you very much. Thank you. Thank you, Rossi.
Well, students have to go back to the classes.